guys, so here's part 1 of the 2.7 extension day 2 notes. What we're going to be doing is writing piecewise functions. Now, first part is going to be with graphs, given a graph, and then the second part is going to be going, how do we write a piecewise function given a word problem? Okay, let's go ahead and begin, start. We're going to skip this part and actually just go to automatically example 1. I think this is going to make a little bit more sense when we go over this problem and need to write a piecewise function. Okay, so first things first, I would advise really use some of the older, like when we actually graphed piecewise function, look at how they wrote their piecewise function when they gave it to you. That's basically our first start, okay? So we're going to use, I'm going to scroll down a little bit so we have some room here. Okay, notation, that is very important. So we're going to have f of x equals in this curly bracket. That's your very first thing you need to put down. Now the next thing, remember we have equations and restrictions. The equations will be on the left-hand side, and then your restrictions are going to be on the right-hand side. Now what I would advise is the number of lines you see on the graph, that's how many equations you're going to find, as well as restrictions. So I see I have 2 lines on my graph here. I have 1, 2. So I'm going to go ahead and create 2 blank spots because I have to create 2 of those equations. And then, of course, we're going to have our restriction here. Okay. Now, you might see this A through E. I'm going to be answering those questions along the way as we are doing this. Okay. So the first thing we need to do is find the equation of our left-hand side. Okay. I'm going to draw a lovely arrow to it. There we go. Remember, when we are trying to find the equation, we are using mx plus b, okay? So we need to find the slope, and we need to find the y-intercept. Now, we've done this already, right, when we are doing lines. So slope, let's talk about that first. Remember, to find slope, pick a point that is on the line, and then you go to the next point. Okay, let's say I start here, I go up 1, and then to the right 1. Up 1 to the right 1. Okay, so since I went up 1, that's positive, and then I went to the right 1, that's positive. So my slope is just 1. Now the nice part here is that our graph does cross the y-axis, so we can figure out our y-intercept. Here, we can see that our point is at 2, so b is going to equal to 2. So now I write that equation. So I have 1x, or you can just do x plus 2. And that's it for that one. Okay, let's find the equation of the other line. We're going to do the same thing. You need to find m, and we have to find b. Okay, find a point that is on the line. Doesn't matter where. And then I'm going to go up 1 to the right 1. Up 1 to the right 1. So up means positive, and to the right also means positive. So I have 1 over 1, which just gives me 1. Once again, we can see that this line crosses the y-axis, and it crosses it at 0. So my b value is 0. So my equation here is just going to be x. Now, you can also write x plus 0, x minus 0. It's up to you, whatever you would like to do, but you can also just put x. Okay, so that stuff should have been reviewed. Now it's going to be coming the new stuff, the restrictions, okay? So when we're thinking about restriction, it's going to be the break in the graph, meaning we're going to look at where the open and closed circles intersect, okay? Now remember, restrictions, it deals with the domain. And remember, domain deals with x values, okay? So when we do this, we have to have x for our restrictions. Okay, so what I'm going to do is I'm going to look, okay, where is the open and closed circle? Okay, right here. Now what I'm going to do is I'm going to figure out what is the x value they have in common. Okay, so you can draw a line if you want to make it a little bit easier to figure that out. I'm going to go ahead and do that. You can see where they intersect. So it looks like that the open and closed circle, that their common x value is 0. So that is the number that we're going to write on here. Now our last thing that we need to do is notice that we did inequality signs when we did our restrictions, okay? Now remember, restrictions is always dealing with x, the horizontal axis. So let's first talk about the equation of x plus 2. We need to figure out, okay, from this open circle, are the x values getting smaller or bigger than 0? Well, notice that the graph is going left, right? The arrow is going that way. So it's going left. Well, if we're thinking about going left, that means, of course, those x values are getting smaller, so we want the less than sign. Now, also notice that this point here is open. Whenever we have an open circle, like we did with absolute value inequalities, we had no equal bar, okay? So with this one, we're just going to have x is less than 0. No equal bar because the circle at 0, 2, or the point at 0, 2 is open. Okay, now let's look at our other equation of just x. So notice that here we have a closed circle, so we're going to have an equal bar on our inequality. But now let's figure out, are the x values getting bigger or smaller than 0? Well, the line is going to the right-hand side, so that means that the x values are getting bigger. So we want to use x is greater than or equal to 0. And that's how you're going to write a piecewise function. Okay, let's try another one. Okay, here we go. Now I might have to, I know it's a little bit grainy here. This one is going to be closed, and then here is going to be open. There we go. Okay, first thing first, we need to do the function notation. That is always your first thing you need to do. Okay, we have two lines. That means we're going to have two equations. And with each equation, we have a restriction. Okay, let's find this line here. So we want the M and we want the B. Okay, pick a point that is on this graph or on this line here. Here's here. So it looks like I go down 2 and then to the right one. Down 2 to the right one. Down 2 to the right one. So remember, down 2 means negative, so down means negative, but I do go right, so that's a positive. So that means my slope is -2. Now, this is where we get a little bit tricky. Notice that this line really doesn't cross the y-axis. So in order to find the y-intercept, we actually have to continue this line to find that, okay? So that means I'm going to use that same slope of -2 over 1 and figure out what is my y-intercept. So I go down 2 and to the right one. Well, it looks like that I cross at -4. So that means my equation here is -2x minus 4. Okay, let's find the second equation. So we have our slope and our b, the y-intercept. Once again, just find a point on here and then go to multiple points just to see what the slope is. So it looks like I go down 3 to the right one. Down 1, 2, 3 to the right one. Down 1, 2, 3 to the right one. So meaning that I went down, that's going to be negative. And then I went to the right, that's positive. So that means I get -3 as my slope. The b, the nice part is here, is we can clearly see that it does cross the x-axis, or sorry, the y-axis. It clearly crosses the y-axis, and it crosses it at 0. There we go. Okay, so now that means our equation here is going to be -3x. Now, remember, you can do -3x plus 0, -3x minus 0, whatever works kind of for you. Okay, our last thing we need to do is figure out the restrictions. Okay, first things first, I'm going to put x, because remember, restrictions always deal with the x. It's dealing with our domain here, okay? Now, I'm going to go ahead and erase some of this extra so we can clearly see where the open and closed circles intersect. There we go. And I'm going to redo this because it was a little bit grainy and hard to see. There we go. Okay, now what we want to do is figure out what is the common x value between the closed and open circle. Well, what we can see is that they align at -1. They both have -1 as an x value. So I'm going to have -1 and -1. Okay. Now, for our green, the negative 2x minus 4, we have to see, are the x values getting bigger or smaller than negative 1? Well, since our line is going to the left, remember that means it's getting smaller. So I want to have less than. Now, also notice that I have a closed circle. So here we want an equal bar. Well, let's look at the negative 3x equation. This is an open circle, so we know we're not going to have an equal bar. Now, also notice that for the x values for this equation, they are going to the right. That means they are getting bigger than negative 1. So we want to use the larger than symbol to represent that. And there's your answer for that piecewise function. Okay, we're going to do one more, and this one's going to look a bit different because now we're going to have three. Whoops, let's go to the next one. We're going to have three of them, okay? Here we are. You can find it. It was right below it. Okay, so now we're going to have multiple, not only just three, but multiple equations here. I really wanted to do this because, one, hopefully you remember what type of function this is. This is a step function. And two, we need to work on how do we write with constants for our equations. And then three, how do we write with two parts of our restriction? Okay, let's first figure out all of the equations. Now notice I have 1, 2, 3, 4 of these, okay? So that means I'm going to have 1, 2, 3, 4 equations. And then for each of those equations, I will have a restriction, okay? Okay, let's figure out the equations for each of these. Now the nice part is these are horizontal. So remember how we write our equations when they're horizontal. They are constant, so they're just whatever the y value is. So for the first one, the y value is at 20. So that's going to be our equation, 20. The next one is going to be 15. That will be our equation there. Then the next one looks like at 10. And then our last one looks like it's at 5, because that is the constant, and that's the y value. So those were nice and easy. Now let's figure out how do we write these. Now the other two problems, when we wrote it, there was only one part to the restriction, okay? Either x was greater than or less than a number. Here, notice we have a segment, so we're going to have two parts to the restriction, okay? Now, when we do this, and if you kind of look back at how it was written when we graphed piecewise function, the x was in between two numbers. So I'm going to put x in the middle, and we will have to have it where it's in between two values, okay? Now, let's look at the first one, so for the 20. So it looks like the very first open circle, now we're thinking of x values. The x value of this open circle is 0. If we go to the closed circle on this, the x value is 20. Now, when we are writing using our inequality signs, the smaller number goes on the left-hand side, and then the bigger number goes on the left-hand, or on the right-hand side, okay? So always go from smallest to biggest. Now, how our inequalities are going to go, the nice part is they're going to go the same way, okay? So they're all going to be less than symbols. Now, the last thing we need to figure out is which one has the equal bar. Well, it looks like at 0, remember that's our x value, that is an open circle, so we don't have an equal bar. But at 20, which is also our x, that has a closed circle, so that will have an equal bar. So at 0 is less than x, which x is less than or equal to 20. Okay, let's try that for 15. So notice, we have an open circle at 20 and then a closed circle at 40. Remember, I'm looking at the x values here. So we go from smallest to biggest. So smallest is on the left-hand side, biggest is on the right-hand side. Now let's think of which one has the equal bar when we write the inequality. So at 20, we have an open circle, so no equal bar. But at 40 here, that's a closed circle, so we will have an equal bar. So we have 20 is less than x, which x is less than or equal to 40. Okay, what I would like you to do is go ahead and pause the video and try the last two. So fill out the restrictions for the last two. Okay, let's see what you got. So for when our equation's at 10, we have an open circle at 40 here, and then we have a closed circle at 80. So those are going to be my two numbers that are right for my restriction. Notice that at 40, it is an open circle, so there's no equal bar. And then at 80, it is closed, so we do have an equal bar. So we got 40 is less than x, and x is less than or equal to 80. And then lastly, for our 5, notice that we have an open circle at 80, closed at 90. So we have 80 and then 90. 80 is going to be open, so no equal bar. 90 is closed, so an equal bar. Now, one thing I do want you to notice is that the numbers repeat. On our first restriction, we have 20, but we still use that same number in our second restriction. Notice that's the same thing here. We go 40 to 40, 80 to 80, okay? So whenever you're writing your restrictions, numbers should repeat, okay? If they don't, that means you have a gap in your graph, which doesn't make it a function. So just make sure you see that pattern that the numbers on the restrictions do repeat. Okay, see you guys in the next video.